Hello, good morning students. So welcome to the online video class. So we'll continue with the chapter functions of operating system. Today we'll be discussing about the different types of operating systems. Okay, so let's check what types are there. So types of operating system. An operating system may be single user or multi-user. So an operating system could be used by a single user or it can be used by a multi-user. So based on that single user or multi-user, okay, we have 5 types of operating system. So in the first type we have single user. So a single user operating system is that operating system which supports only one user at a time. For example, DOS, Windows 95, 97, 98, etc. Single user can be single user single task or single user multitask. Okay, now here this is an operating system. Okay, it can support only one user at a time. Okay, so only one user can use that operating system at a time. Most uh, basic example is your MS-DOS. Okay, Microsoft this operating system, which was the first operating system that was created by Microsoft. Okay, so however, maybe some of you have used that those commands, right? Okay, in that consolidator you run the commands. Now for users, okay, earlier times for users or even now also, okay, if you want to use the MS-DOS, okay, you have to learn the commands. So without learning the commands, it is very difficult to use that operating system. So that improvement was done with the GUI based operating system that came under the word Windows. Okay, so because of that Windows GUI operating system, Microsoft became very popular. Okay, so that being said, okay, single user single task, so that can be MS-DOS. Okay, and single user multitask, you can use Windows. Okay, Windows can be used as for by a single user for doing multitasking also. Okay, you have your own system, you can do multitask like that. So next we have is multiprocessing. In multiprocessing, a computer uses two or more CPU or two or more processors at the same time. Instructions from different and independent programs can be processed at the same time by different processors. Multiprocessing is used for nations major control applications such as railroad controls or airways, etc. Okay, so a computer that uses two processors at the same time, okay, and executes the instructions that is being given, process the programs by the two processors at the same time, so that is called as multiprocessing. Okay, so this is a very efficient way of using the processors, that is the dual processor. It can be two or more than two processors. Okay, so you make efficient use of all the resources and the CPU like that efficiently. So you must have heard of like the dual core processors like that, right? So you have two processors, so at the same time you're able to do multiple works by the two processors like that. So examples such as like here you have your railroad controls or airways. Okay, your your operating systems like Windows 7 and all. Okay, so it can also be done for multi-processing provided you have the dual processors like that. Okay, next we have multi-programming. So do not get confused between multi-programming, multi-processing, multitasking. Multi-processing is related with hardware when you have more than two or more processors. Okay, multi-programming, the word itself says programming. Multi-programming or multitasking okay, is related with the computer software, able to do multiple tasks or do multiple programming. Okay, so uh, try to understand the difference between multi-programming, multitasking, okay, and multiprocessing. So multi-programming, several jobs are kept in memory at the same time, okay, in the main memory, so like in the RAM. The more the number of programs competing for system resources, the better will be the CPU utilization. By organizing jobs so that CPU always has one to execute. During execution, the process may need some input-output operations to complete. Okay, here in multi-programming, okay, like example, you have your own system. Okay, you have your own system and then you run your Windows 7 operating system like that. You have a single processor, and with that single processor you are able to manage multiple programs at the same time. You're opening your MS Word, you're typing some notes, okay, and then you're listening to your musics, you're listening to music, okay, and at the same time, let's say like you're accessing internet, you have opened your web browser and then you are downloading something, right? So you can see that the processor is managing all those activities, processes, jobs at the same time, okay, not not one after the other, okay, not one first job let it be done and then second job let it be like that, not like that, okay. It you it to the user it looks as if like all the jobs are being done simultaneously at the same time, so that is called as multi-programming, okay. So it makes efficient use of the CPU, okay. So during the execution of that, you require some input output operations, some like the monitor, it displays the keyboard, you're making some work, typing something from the keyboard like that, right? So that is multi-programming, okay. Now time sharing or can also be called as like multitasking, right? So time sharing allocates a small amount of time for each job. In other words, time sharing refers to the allocation of computer resources in time slots to several programs simultaneously. For example, a mainframe computer that has many users logged onto it. Each user uses the resources of the mainframe, that is memory, CPU, etc. So the time sharing in multi-programming looks a bit similar, okay, but there's a difference in that. Time sharing, what happens is that a time limit is allotted for each job, okay. Limit is allotted for each job. So uh, the allocation of the resources for all the different programs, okay, is given a time sharing slope like that. So upon execution of the first, while it is running, okay, the second one is waiting like that, okay, and then the CPU informs the third one, okay, to be next in line like that, okay. So here example you have here is a mainframe computer where many users are connected. Just imagine that the mainframe computer is in the circle, okay, and users computers are connected from all angles to that particular mainframe computer, right? And then so many users are accessing the mainframe computers, the memory, the CPU, like the resources, right? So the mainframe computer will allocate the resources to each user, okay, according to the time frame limit like that, okay. So that is called as time sharing. So next we have real time. Real time processing method is one that controls the environment by receiving data, controlling them, and taking actions or returning results sufficiently quickly to affect the functioning of the environment at that time. So as the word itself says, real time, in actual life of time, okay, at the moment like that. So it controls the environment, that means like the real time, okay, by receiving the data, okay, and then processing on the data, okay, and returning the results quickly, immediately, like that. Okay, so real-time systems are basically online systems, okay, so related to online, like the airlines flight seat availability, okay, immediately you get the details about whether the flight seats are available or not, right? You check it, and then maybe before it there was not, it was not available, and then after, let's say after 1 minute you check it again, and then there is say like one seat available, right? So that is a real time processing going on. Okay, so like a wholesaler supplies and manufacturer availability of stocks. So real time usually operates in the multi-programming and multi-processing section, okay, in the multi-programming and multi-processing section. So real time operates on that, like weather reports. You get immediate weather reports, be it on your mobile phone or be it on your computers, like that, right? Be it on any digital equipment gadgets, like that. So you get the real time update. So that is with the help of this real time uh, real time processing. Okay, so that is possible with the help of this distributed operating system. Oh, sorry. So next we have the distributed operating system. Okay, so user access remote resources as they do local resources. Okay, so remote resources, I discuss about real time also. Okay, so remote resources, so the it may not be that, okay, user is trying to access information that may be far away, like that. So it is distributed. So there are a variety of reasons for building distributed systems, the major ones being this. Okay, resource sharing. If a number of different sites are connected to one another, then a user at one site may be able to use the resources available to another. Okay, so you have, let's just imagine that all the different computers are connected one to another. The most basic example of distributed operating system is your internet, right? So through internet, all the computers, all the devices are being connected, right? So that is in terms of the resource sharing. So what happens is that a user, if a user is connected to another user, so and one user is like acquiring information from that user, let's say A and B, like that, right? So they can share the resources one to the other, like that. While one is extracting information, another can also extract information, like that. Okay, so that can be done as in resource sharing. So next one is computation speed up. If a particular site currently overloaded with jobs, some of them may move on to highly loaded sites. This movement of jobs is called load sharing. Okay, so it is possible in distributed operating system. That is why we another example, we have the internet. We have this what is called as client server, peer-to-peer networking. Okay, so how you are able to extract information through the server, right? So in case, if just example, like you're trying to extract certain information, right? Now it may be that you have you're trying to extract information from multiple servers, because one server may have some data content, okay, another server may have the rest of the data content, like that. Okay, so but it may assume to you that you're getting the information from one single computer only. Okay, though the data you're searching for, it may be distributed with different systems, okay, or different servers, okay, but when you receive the information, okay, you do not know. It is assumed that you think that, okay, you are extracting the information from a single computer or from a single server, like that. Okay, so what happened is that because of that, because of this interconnectivity, okay, the load shared with the job is also lightly loaded. Okay, so that is called as load sharing. Next is reliability. So if one sites fail in distributed system, the remaining sites can potentially continue operating. Okay, this is very much essential. Okay, it should be very reliable, especially in terms of internet, right? In terms of distributed operating system, if you are trying to extract information and let's say that that site crashed, okay, that information gone. So what will happen? You cannot extract information anymore, right? But it is not so in distributed operating system. Okay, that is provided if enough redundancy. I mentioned to you, I might have mentioned to you regarding the word redundancy, that is duplication of data. Okay, if not redundancy, it means duplication of data. Okay, so the same data gets duplicated like that. So exists in the system both hardware and data. The system can continue with its operation even if some of its sites fail. Okay, so I'll discuss about this word redundancy later in the coming chapters. Okay, but it just a brief explanation, like see in this case, if enough redundancy exists in the system both hardware and data, that is hardware and software, okay, the system can continue with its operation even if some of its sites fail. Okay, so that means like you're trying to extract the information. Okay, let's say that one of the server fails. Okay, but if there is enough server, okay, and since let's say that every server has enough sufficient space to duplicate the data that you are uh, searching for, and the same data that you're searching for is located in different servers also. Okay, so what will happen is that if one server fails, another server, you can extract information from another server like that. Okay, so that is what happens in a distributed operating system when regarding reliability. Okay, next you have is communications. So there are many instances when programs needs to exchange data uh, with one another systems. Okay, so there is a word that has been misspelled. Okay, so user can initiate file transfer or communicate with one another via this email. So communication can be done by email or file transfer like that. Okay, so that is possible in a distributed operating system like that. So the next one we have is the network operating system. Okay, students, just to mark that, okay, that topic, network operating system, does not come under the distributed operating system, but it comes under the types of operating system. Okay, so network operating system. Okay, so a network operating system is an operating system that manages network resources for connecting computers and devices into a local area network. It provides the following services like file and printer sharing, backup data, user account administration. Okay, so anything that is connected to the network comes under the network operating system. It may be a LAN connection, it may be a LAN connection, WAN connection like that. I'm sure that you know what is LAN, WAN, MAN like that, right? So and then that shares the resources, uh, say like in an office like that, right? You have your printer, so it is not possible that every computer will have one printer, right? So you may have two three printers that will be shared with all the computers. Okay, so that is what is possible in the network operating system, and it may be connected to a central server where the files can be shared and the files can be backed also like that. Okay, so that is comes under the types of operating system, that is network operating system. So that will be all for today. Okay, in the next class we'll discuss about some of the popular operating systems. It's just a small topic. Okay, and then yeah, so that will be all for today. Okay.